Write it down. I want to see who knows it and who doesn't. So what the students are doing now is they're all trying just to write out the equation. Have you find a hypotenuse using the Pythagorean theorem, and then what I'm going to do, Shannon, I'm going to be able to find out exactly who knows it and who doesn't. It's going to show me. So the students are sending it to me. I can see by this little blue bar that students are already sending. If you don't know it, maybe put a question mark or something. And so I'm going to come up here, and I'm going to get to see a squared plus b squared plus c squared. If it's right, say yes. If it's wrong, say no. Is it right? No. No, it's not. All right, a squared plus b squared equals c squared. Yes. Some of you are unsure. And then if you look here, a plus b plus c. And a squared plus b squared. This is it, everybody. To find the hypotenuse is a squared plus b squared plus c squared. A plus b squared equals c squared. It will work for any triangle, correct?
No, sir.
Why not?
It will not work for any triangle because the only way that you can use the only way that you can find the hypotenuse is if the triangle is a right triangle, which means that the triangle has at least, well, it can only have one right angle.
Excellent. So the deal is, if you want to find the hypotenuse, which is the line across from a right angle, you got to have a right angle. Problem is, when we look at this triangle, is there a right angle?
No, sir.
There's not.
I'm gonna say you can make one because you see, oh, it's one triangle, but you see right here, right down that line, you can make two triangles, which will be a right triangle. So I'm saying you can make a right triangle.
So you could make a right triangle. So we already know 8 and 6, and we know 12. So I want to know if I add this plus this plus this, not counting those two sections, I want to know the total. Just that side plus that side plus that side. That is a total, everybody, of
26!
All right, you said 26. Let's come double check. I thought some of you may say 12 plus 8 plus 6. And you all did. And you're wrong. Oh. Excuse me.
Yes, sir. I think the problem that we made is that we have to count up all the sides, and all the sides includes this right here.
The problem that everyone made is that, thank you, Gregory. And what I think that the problem that everyone made is that 8 is the height of the triangle, and 12 is the height of everything. And so
I disagree with both of you. I think what you're trying to say is that 8 is the height of the side of the square. So that means that if it's a square, or the rectangle, sorry, if it's a rectangle, the opposite side would be the same size. So you would add 8 plus 8 and 6 plus 6 to find the perimeter of the rectangle.
Jordan, thank you, but I actually I disagree with you. You wouldn't add 6, you would only add 6 once because you're not counting that top part right there, you see?
Is the Mario on? Wiper down! So I'm a little shocked, everybody, that this was so hard for you to do, because all I said for you, and I even kind of showed you I was doing it in a tricky way, I said this plus this plus this. I said not the whole side, just this, and then you went ahead and added it. If you add that 12, you're going to get the problem wrong. That 12 has nothing to do with this perimeter. And so what you would do here is you would say, well, 8 plus 6 plus 8. You would not come inside. You stand on the outside. So 8 plus 6 plus 8, that would be a total of 22. But now you have to get that and that. When you do the Pythagorean theorem, what is this going to be? What is this going to be in terms of letters? A. This is going to be B. And then this is going to be C. So if you say a squared plus b squared equals c squared, you can figure out c, add them up, and then get your total. I want you to figure this out, and then I want you to put your total in there. I want to see if you can get the right number of the total perimeter in there. I'm going to send it out to you now. And so here we go.